Alright, so first thing we're going to go over is the last week Affine Cipher. Just going to quickly run through it. Everyone who submitted a valid entry, but I'm just going to quickly run through it here. And last time we actually had our multiplicative N cipher and multiplicative D cipher that we made in class. And I'm not going to spend a whole lot of time going through this. I'm actually just going to copy and paste the multiplicative N cipher and D cipher that we had from last week and just kind of show what the difference is for the affine. So we're going to say define affine and cipher. Text, same thing, but instead of just key, we have two keys now, A key and M key. This should all be old news. Quickly, grab all of this, because this is all the same for all the N ciphers we've done so far. Only thing that... Yes, I was going to share my screen. Thank you. Alright. So, yeah, here we are. Are you seeing the right thing? Okay. Sorry about that. Okay, so, our affine cipher is pretty much just the Caesar cipher with a multiplicative N cipher on top of it, or the other way around, however you want to look at it. So basically, all the lines above this on the N cipher are the same, all the lines below are the same. This is our magical line, which it's still fairly similar, but it is not quite the same. We take our plane number, and then we multiply by our M key. After that, we add by our A key. Like last time, we take our modulo 26, because this is way more likely to go outside that boundary of 26. And we can just copy the rest of this from earlier onto there. I can see for some reason it's going to have a little error here. I saw this going through earlier. Just have this. You can see this little red text, little squiggly here. This is good knowledge for debugging. Whenever you see that little red squiggly line, it means that you're going to have some sort of error with your code. And I happen to have been debugging on that earlier and know what that means. If it's at the very last character or the last word, it means that it is an indent error, which just means that these little indents here are just inconsistent. You can just see what I did there was I just kind of deleted it and put it down there, just kind of refreshes it. Anyway, we're going to go through here. Our print affine and cipher are going to have our text, affine cipher, and then we have our M key, we'll just call 5, and our A key, we'll call 8. Print that. Oh, forgot to have the text clean. My bad. Text equals text clean of text, which of course, if I'm going to call this function, I need to have this function. So I'm just going to bring this up at the top. Now if we run that, we have our cipher. Now the D cipher for affine looks very similar to the multiplicative D cipher. I'm actually just going to take the entire thing and just drag it over here, change the name to affine, change the variable. What's inside this function are the variables, and we have a third variable. We have our text, we have our M key, and we have our A key, which is different. Now the only difference that we add is we subtract before we multiply. I explained this in the affine cipher, like the abstract. This is now just putting it into code. So we're gonna minus a key, put another parentheses right there, and now it is a working piece of code. We're going to print our affine decipher, and our variables, we'll just say, I guess I should take this. So what I'm going to do here, as like I did last time, is I'm going to make, I'm going to make this a variable, ciphered, we'll just call it, is this variable, and then we're going to say print affine ncipher, or sorry, no, just print ciphered, and then if we come down here, we can say print affine decipher of ciphered, and then our keys, which were 5 and 8. I'm going through quickly because, because this should already be, this should be review. I forgot to change, however, this key in here. Only have to change it to M key. M key is the only thing involved with this inverse function, and there we have our affine cipher explained really quickly. This is being recorded, as you know, if you're watching this after the fact. So if you want to get a review, that is an option. So that takes us to the point of today's lesson. We are going to take a short break from cryptography. We had our a couple weeks of that. We're gonna return to it, but we want to take 1 week off to line up with this whole YTAC Rocket League big STEM presentation. If you guys don't know, next Friday, today is Thursday, next Friday, a week and a day, we are going to have our big stream for the championship of our Rocket League tournament. We're also going to have some display of our other STEM teams. And what we're going to have here is something a little bit related. I'll go through and explain what we're doing first, and then I will tell you the increased reward, the booty for this week, which will not be chosen through a raffle. This is week 3. Week 2 will still be chosen for a raffle if you submitted an entry, but week 3 will be submitted, and what gets the money will be the one that has the best code, not just if it was submitted. So, what are we going to do? Well, we want to have another, tie-in to YTAC. We're all one program. We're going to have something a little bit related to what's going on right now. We're going to have a little choose-your-own-adventure game, but it's going to be themed around Rocket League. So before I go into what a choose-your-own-adventure game would look like, I'm going to show you a few of the things that you're going to need to know in order to make one. The first item that I will show you guys, which is the most important part about the choose your own adventure, is choosing. So that requires an input from the user. Whoever is running your code wants to be able to choose, so we're gonna ask them something. So how does this work? What do we do here? Well, what we're gonna have is we're going to start, of course, with print. You always start with print because that's just how you're going to see this in this sidebar where our results are. So what we're going to do here is we're going to say, we're going to have our first, title, and we're going to say what's going to happen. So we're going to have our quotation marks, and we're just going to say, choose your own adventure. This will just be like, our, we have it right here as that's what's happening. And then we're going to have an input. So we will say input equals, not input equals, input parentheses, and then we're going to say, hello. right? Very simple. Now we have an option to input here, and we can type in this. Since the program said hello, I will say hi back. That's all it does right now, because all we have is to take this input. Basically, if you don't have this set to a variable, we'll say this is our greeting equals input hello. Greeting is like the basket where you're putting this input. You've just gathered this input. If you don't have a variable, you're just throwing it on the floor and it's useless. If you have this basket, you've grabbed the input from the user and then you've put it in this basket. So now what we can do after this is we can say print greeting, and now we can say, choose your own adventure, hello, I'll respond howdy, and then it will print howdy. It'll print what I said. All of these will be important for what we are going to be doing in this for this Telltale, this adventure game, because it's like I said, this is going to be Rocket League themed. So basically, this is going to be sort of like a guide. That's sort of like a tentative guide. Imagine if you're playing Rocket League inside of this. There's no picture. It's just, words, verbiage. So it would say, this is just a hypothetical. You're going to design this how you want. You could make this do whatever. This could be a training. This could be like, something response to help players. But I'm just going to say for a hypothetical, we'll say our first, our play is, we're going to say our input, it's going to ask the user, well, it's going to say, the ball is in the air in front of the net. Okay? And then we'll ask it, what do you do? And then we can give it some options. We can say, do you jump and aerial? And then we can say, or just wait on the ground. So now, what we can have is, we run this, we say, ball's in the air in front of the net. Do you jump in the aerial or just wait? If I say, I could just say, chicken, or chick, That doesn't answer the question. So what we want this to do is tell the user what the answers are, or like how this will stem. I'll show you guys a great example of this after. But we want this to, we can't just have the user input anything, because we can't account for anything. We don't have this AI to determine what they're trying to say. So what we're going to say is, what's a good way to do this is you can say aerial in parentheses after that, and then wait. So now this is telling you, if we run this and we look at it, what I'm actually going to do here is separate this, so that way it's a little bit easier to see. Because right now it's kind of getting all cut up over here, so we just want this to format to look better. Because the point of this is for the reader to be able to choose where this is going. And then we're gonna have our quote here. So now we have, what is the error message here? Invalid syntax. Hang on. So basically, I'm going to explain why we're doing this part. We want, here it is. There was a open parenthesis without a close. So let me quickly explain. We wanted to separate these lines so that way it was a little bit easier to read. It's starting to get clumped up. The reason we have this input is it's asking what you're going to do, and it's giving you your options. The point of this game is to sort of, the user will be confronted with a couple of options, and then they choose which one they take, which path they take, which road they will follow. So now if we run this, we can say, the ball's in the air in front of the net. What do you do? Jump or an aerial, or just wait? So now it's telling us what our options are, aerial and wait. So if I say wait, because it was told me to, well, right now we don't have it do anything. We only have it print wait. So this is where the next part of this will come in to make your game, um, you know, able to detect what the user does. Right here, you know what they said, but can you compare it? So we're gonna go and we're gonna make what's called an if statement. An if statement is a conditional. It's a Boolean. Basically, it checks if some event is true, hence the if. So what we're gonna do here is we're gonna say if play equals equals. If you remember from earlier, you want equals equals to check if it's if the value is the same as something. You use one equal if you're setting something to it like a variable. And if we say our play is wait, then what we're gonna have our colon inside. You can see we're indented now, so we are in this. We are inside this if loop or this if statement. We can print a message that now says print. The ball was blocked before it landed. That's what we'll just say, and then we'd have another. We can say something like this: enemy scores and you lose. Right? This is very like the simple part of it. So now we're gonna go through this. What do you want to do? Do you want to jump? Do you want to wait? We're gonna say wait. The ball is blocked before it landed. The enemy scores and you lose. This is now one step on one road. So if I were to make this a like a diagram, it'd be like if you've seen a family tree, you have two options, and then it splits off into two more. It splits off into two more as each of them have their children. In this case, as you progress through. So the point is to make the best choose your own adventure game. Before I set you loose, I'm gonna show you how to accommodate for the other thing. Because right now, if you don't choose wait and you choose aerial, the program just ends. So this is where we're gonna implement another type of function. We're gonna say for this, we're gonna say else. Now, basically what this will check is it'll say if this play, this variable, which is based on this input, if play equals the string wait, then it will do this. If it does not do this, if it's something else, now we have this function. Again, we have the colon and we're indented, so we know we're inside this else. Then we'll say, in this scenario, if they didn't pick wait, they picked aerial. So we'll say print, and then we'll have it say you score and win. And then we could just say simply like that, what do you want to do? We'll say aerial. Now it says we score and we win. So you can see where this is going. We'll have this compound and go further. And then once you're inside this if statement, you would say, I don't know. Let's say it doesn't say enemy scores and you lose. We'll just say the enemy takes the ball to your goal. All right, now we're going to say our retaliation. That's going to be our new variable. This is going to equal an input that says, do you go for big boost or little boost? I like to put a space at the end so that there's a little bit of room, and we'll just we'll label these so that the user will know what to say. So now if we run this, we're gonna say wait, and now ball is blocked. Enemy takes the ball to your goal. We'll go for a big boost or a little boost. Big boost, and then you can see where this would string on continuously. By the end of it, you should have different paths. You should be able to, well, I'm going to choose aerial or I'm going to choose to wait. And then the next time Once I've choose aerial, I'm going to go down this path. Or once I've choose weight, I can go down this path and go down a string. Or if I can go, there should be many options by the end. Another important function that you will use for this, if else statement is something that's called an elif. So an elif is like else if. Basically, it's saying if play is something else, it'll check if it's that. I'm sorry that was very confusing. Let me just print it right there. So what elif is saying is it's sort of if initiates this conditional, elif checks for something else. Else is whatever remains. So we're going to say elif play. We're going to say, I don't know. You could have multiple examples. Like, what do you want to do? Do you want to jump, aerial, or just wait? We can add another option. Or get on defense. Now we have another option that would warrant this elif. Which we could change this, tell the user to say defense. So if play equals, quotations, defense, our colon. Now we're in a new indent, and it would say print. No one scores. It's a tie. Now, if we run this, we can look at this. All right, we're gonna say we're gonna go on defense. No one scores. It's a tie. It used this. It's not play. It checks this. Oh, it is defense, and then it goes and runs through this string here of text, however long it would be. If we have our set to aerial, it'll be, well, is it play? No. Is it defense? No. It must be something else, which in this case is aerial. You do not need to have an else with any if statement. You do not need to have an elif with every if statement, but you cannot have two ifs in the same statement. I hope that's clear. Something else I want to quickly mention is that you have pretty much free reign over this. It doesn't really have to. It could be a guide. It could be a storyboard. Whatever you want to do, it's going to pertain to Rocket League. This was a very simple example, but I'm going to show you now a much better example by Ethan. This one, oh yes, of course. So this one, you can see it has a lot more. We have 205 lines. And you can see that most of the lines are just elif, prints, and variables. Some form of if. And basically we can, go through this and we look, there's even like a health and money stat. So we're going to go to the output. This is a very nice style that lets us view it. You can ask, welcome to the first game. What's your name? My name is Brian. Can't even spell. How old are you? I am 18. Hello, Brian. You are 18 years old. You're old enough to play. Do you want to play? Yes. Would you like to go right or left? And now I can just play through this. Let's see. I see a mountain range with a lake. Do I go in the mountain or in the lake? I'm going to say mountain. I'm a mountains guy. Now we can see I travel up. This is a story that's coming through as I have chosen. I chose to go right. I chose to go to the mountain. You can make this however long or short you want, but the best will win. And the nice thing about this is at the end of the adventure, it sort of shows me my string. It tells me where I went, how much health and how much money I finished on. But if we run this again, we can try. My name is Markers. How old are you? I am 12. I am not old enough to play. So you can have things that will, conditions that will change the game, and it's something that will take longer, as you can see. Because I was 12, this integer was not large enough to make me able to play. So, it ended. If you wanted to in your Rocket League, you could say, you chose wrong, the enemy scored. you lose. Or you could say you chose right, now what do you do? You chose right, now what do you do? And you continue to go through that path. You can have it as something like a story like this, where if we look at the code here, we can see that if you go, it's not like you chose right and you win. If you choose left, this is the left or right if statement, you see a village and a caravan. This gives you another option. So you can continue to go down the line and have different options and different scenarios, or you can have it so that there's just one correct way and the user has to go through and find what's correct. Does anyone have any questions? If you do have questions you don't want to ask during class, you can DM me, but does anyone have any right now? So this will be due. I should probably tell you guys about the finale, the rewards and stuff. So the stream starts for the Rocket League tournaments and STEM YTAC presentation. That will be on Friday evening. So I will accept these adventure games as late as, I'll say, Friday at 4 o'clock is the latest I will accept them. I would prefer if it was in before Thursday, but things happen. This week, like I said, the winner will be chosen based on merit alone. There will be no luck. And the winner will receive $50, as well as they will go on that live stream, the YTAC Rocket League live stream, and present their adventure game live on Twitch. If you do not want to present live on Twitch, you do not have to, but the winner has that option available to them. All right. I'm going to end the recording now. If you have any questions, feel free to DM me. Thanks for watching.